All right, day 23. Let's hope it goes well. Coprocessor conflagration. You decided to drag the CPU and fix the printer from there. As you get close, you find external coprocessor is doing so much work, the local program is so afraid it will halt and catch fire. To cause serious issues, hit and see what you can do. The code it's running seems to be variant of the kind you saw recently on that tablet, day 18. General functionality seems very similar, but some of the instructions are different. Set, sub, mul, gens. All the instructions above are used. 8 registers here, all set 0. The coprocessor is set to some kind of debug mode, which allows for testing, prevents it from doing meaningful work. If you run the program, how many times is the mul instruction invoked? Okay. So, since it's saying it's going to be similar to day 18, let's get some of the files from here and see what we can do. So what do we call this? Coprocessor conflagration. Day 23 conflagration. Is that right? Conflagration. Okay, so let's see what we can use and what we can't use. So instruction. So that's fun. I always had second thoughts after I did that one. Because I felt like instead of doing args in that dumb way, I should have done arg1, which is a string, and arg2, which is union of a string and int. So, and equals none. So, I had a bunch of registers. And I don't think I'm going to need this last note, so I'm going to get rid of that. Get self name or value string, try return int name or value, accept value error, return self.registers, name or value, that seems right. Def apply instruction, state arg1 equals instruction.arg1, arg2 equals instruction.arg2. So let's see about this. And a state is the register is here named A through H. I'll start at 0. Run. When I run, well, let me just leave with this. Set xy sets register x to the value of y. So if op equals set, state state.registers arg1 equals state dot. Actually, let me just add set. That'll be easier. Set self register string value int goes to none. Self dot registers register equals value. Okay. So state dot set arg1 state dot get arg2. Okay. So that's fine. Sub xy decreases if op equals sub previous value equals state dot get arg1 and then state dot set arg1 previous value minus state dot get arg2, and then only the instructions listed above are used. So there's no add. There is a multiply. previous value equals state.get arg1 state.set arg1 previous value times state.get arg2, and then gens is the only other one. So when we run, while true instructions program position, if instruction op equals gens, jumps with an offset of the value of y, but only if the value of x is not 0. So x equals, should I just call these x and y? Maybe I should. There we go. That's better. I don't know why I'm bothering to rename things, but I am. X equals instruction.x, y equals instruction.y, state set x, state dot get y. I think the code will be more readable this way. Not that I know why it matters, but you know, like I said, this is one of those where I thought, where I did not like some of my design choices after I thought about it more. So now they're giving me a chance to do them, redo them. Okay. So while true, if x equals, okay, if the value of x is not equal to 0, so if state.get instruction.x is not equal to 0, gens, then I want to jump pause plus equal to state.get instruction.y, else pause plus equals 1, I think, because and then otherwise apply instruction to the state and position plus equals 1. If pause is bigger than 0, pause is len program terminated. And let me remind myself of what this was supposed to do. So you register continuing off either end of the program terminates it. So if it terminates it, I don't actually want to raise a runtime error, do I? I think I just want to break, right? Print terminated and break. I think that's right. If you run the program, how many times is the mul instruction invoked? And so save as day 23 input.txt. So I don't even have a test case. They didn't give me one. So day 23 strip new lines program equals parse raw print and so I want to know how many times is the mul instruction invoked. So in order to do that, mul equals 0. Instruction if instruction dot op equals mul, mul plus equals 1, and then finally at the end I want to return mul. So let's see if that works. int argument must be a string of bytes such object or number, not none type. So that is an apply instruction state. Okay, print instruction, print state dot dict. Instruction op equals set x equals b comma 57 y equals none. Okay, so my parse is wrong. Instruction field 0, field 1, field 2 for field inlines. So let me try that. Index error list index out of range. So how can that be true? List index out of range. Print pause len program. So let's try that again. So we got 32 and 32, and if pause is bigger than or equal to len program, so 3025. Okay, well, let's try it, see if it works. If not, we'll need to read our instructions more carefully. That is the right answer. Okay, good. So we don't need to read our instructions more carefully. Now it's time to fix the problem. Debug mode switches wired directly to register A. You flip the switches. Now makes register A start at 1 when the program is executed. When the coprocessor begins to overheat, the frame didn't choose. You need to optimize the program. After setting register A to 1, the program will run to completion. What value will be left in register H? Okay, so and let's initial initial registers dict string comma int equals that. That's, yes, dangerous default value, it would tell me, because you shouldn't do that. But anyway, what I will do is that for kv in initial registers dot items state dot set k v. And so that will allow us to do that. And let me comment out those print statements because they are messing things up. And let me just run this again. Name dict is not defined. That's fine. 3025, is that what we got before? Yeah. Okay, good. So now what I want to do is I want to say, so this is part 1. And let's say part 2. And let me just change this as well to return the state. So return state, and let me run it again and make sure that works too. State equals run program, print state dot dict, and let's just let this go. And the state has registers, but just print mul, that's fine. There you go. So now it's going to return the registers, and that will allow us to look up what the value is of. So again, program equals parse. I probably don't need to do this because I don't think I'm changing the instructions, but I'll just do it again anyway. state equals run program, and now the initial register is A to 1, and print state dot dict. And is this the sort of thing where it's going to, let's see, you'll need to optimize the program if it has any chance of completion. So the code processor's ultimate goal is to determine the value left in register H once the program completes. Technically, if it had that, it wouldn't even need to run the program. So we are going to need to do some reasoning about this. So we set B, set C. A is good, so we jump forward 2. We multiply B. We make B a really large negative number. We make C a really large negative number. We subtract C off. Set F, D, E, G. Okay, so let's reason about this. We want H. We're going to subtract 1 from H every time we get here. Not here. This won't joins us. This won't joins us. This won't joins us. This won't joins us. This won't join. So we're never going to jump here. So the only time we're going to subtract off H is when we do this joins and F is 0. And that means that we're only going to do that if we get this joins and G is 0. So let's think about this. There's got to be some trick here, which is that let's say we ever get to this place, okay? Then we set G to B, and B is some really small number, and then we subtract off from G C, which is also some number, jump forward 2, subtract B 17, Juns 1 minus 23, and Juns 1 minus 23 is always going to happen. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay, so basically this thing is going to loop over and over again. So, and it's still running, so we're really going to have to reason through this somehow, which sucks, but that's life. So we set B to 57, set C to B, multiply B by 100. So now the big difference here is that we've set A to 1, which means the first time we get here, okay, so when A starts in 0, we do this Juns 5. We skip all of this stuff, and then we just go through the rest of it. Now we start with A being 1, and we just skip that jump, which means we set B to something really small. And so we have this B and C. And every time we go through here, D is 2, we set G to 2, we multiply G by 2, and then we jump, F is 0, E is minus 1, set. So let's just go through this. And this is going to be like super tedious, but I don't know what else to do. Because this is going to run forever. Okay. So at this point we have B57, B57, C57, Jun's A2. So we go B5700, C57, and then we go minus 100,000, so that's negative 94,300, C57, and then we want to set C to B, so that's, C negative 94,300, and then I sub C minus 17,000, so if I take another 17,000, that's minus 111,300, is that right? Seems right. 111,300, and then I set F to 1. F1. I apologize for how tedious this is, but I don't know another way to do it. D2. E2. Set G to D. G2. Multiply G by E. So G4 sub GB. So I subtract that. So now G is 94,304. And now I Jun's G2. So I skip that one. Set F to 0. So F is 0. Sub E minus 1, so that means I add 1 to E. So E is now 3. Set G to E. So now G is 3. Sub G B. So now it will be 94,303. Jun's G minus 8. And so 1, 2, 3, 4, 5, 6, 7, 8. Set G to D again. So 1, 2, 3, 4, 5, 6, 7, 8. So now let me call this jump and say, actually, you know what? I'm just going to, well, I'll do this. That's fine. Set G to D. So first, let's start with this guy and see what happens on each of these jumps. So set G to D. So G now becomes 2, which happened last time. Multiply G by E. So becomes 6, right? And I sub G to B. So that becomes 94,306. Jun's G2. That's fine. So I skip the set F0, but F is always... Okay, so I already screwed this up. Good. Let me go back to this thing. So what am I trying to find out? I'm trying to find out just the name of the register, right? So let's do the following. I just want to step program pause int state state, and it's going to return let me do this. Class program state is a named tuple. Program is a program. Pause is an int, and state is a state. And def step self to none is let's just going to copy this. Instruction equals program if state.get instruction x equals 0. And let me do I totally lost what I wanted. And let's say terminated bool equals false. Step self none. So I have instruction self dot terminated equals true. So let's just say if self dot terminated return. So don't do anything. And now let's just say program equals parse raw, state equals state dot set a1 and ps equals program state program 0 state. So I think I forgot to close this quote. So let's do ps and let me add one more thing because I don't want to see the program every time I do this. So, you know, def repr self string return what do I want? I want pause program pause new line and then state dot dict. So let me try this one more time. I mean, pause is not defined. Self.pause, self.program, self.pause, self.state.dict. So let's see. Self.pause equals 0 or self.pause is bigger than length. So I gotta add a bunch of selfs here because now applying instructions self.state self.pause equals 1 and I don't need to track this anymore. Self.pause, self.pause, self.state, self.state, self.program. So let's run this again. Break outside loop. Let me just do this. This is day 23. ps.step attribute error can't set attribute because it's name tuple, and so it's not mutable. Definite self program pause int state self.program self. And I don't need to put pause because we'll just start it at 0. Self.pause equals 0. Self.state equals state. Self.terminated equals false. And so now I don't need to put in 0. Program state, program state. Colon. Parameters to generic types must be types. Well, that's interesting. Never seen that one before. Self.pause plus equals 1. Attribute, no, that's a different one. That's a different one too. Type error. Something bad's happening that I don't even know what it is. No. Something to do with this, I think. ps.program. So that's wrong. That's the problem. So when I took this out, self.state.dict. Okay. Okay, so we do A1 B57, A1 B57 step 2, step 4, step 5, step 6, step 7. I'm actually going to shrink this down a little bit, I apologize, but 9, 10, 11, 12, 13, 14, 16, 17, 18, 19. It goes back to 11. So we get to 11, we're here. Previously at 11, we had this. And now we have, what's the difference? A1, B is the same, C is the same, F is 1, D is 2, E is 2, and now we have this huge negative G as well. So E increased by 1. So let's step through until we get to 11 again. Because actually we want to know what's happening to G. Damn it, that was the wrong thing. Okay, so now G went up by, so let me write these down. So at our last 11, so at step 11, or actually should I do it at 11 or should I do it at 19? I think I should do it at 19. At step 19, we have have this, and then let's go to 19 again, and then we have this, and then we have let's go to 19 one more time. We have this. So basically each loop through at 19, we are going to end up with sorry. So, and we're printing the value at the end, is that right? So, so if I step, I print the state afterwards. So, am I printing the state afterwards? That seems a little bit weird because it seems like, oh yeah, it does. So I want to set G to E. Instruction. I feel like something strange is happening. And that's the following, that because I'm printing the next, sorry, that's the next instruction. So that's really, that's actually really irritating. So let me, okay. Here's what I'm going to do. I am going to print self, and then, and actually, you know what? I'm going to print self.state.dict. So that's my state, and then I'm going to print self.pause, comma, instruction, and then I'm going to print self.state.dict again, and then I'm just going to print something empty. So, sorry, this is taking a long time, huh? But that's okay. Okay, so exit. Let's just start over again. And it's still angry at me because I didn't close that thing. Okay, so I have PS, PS.step, PS.step, and I still am not right because I want to print the final state at the very end. So let me try that again. It's good. Okay, so now we can get back to what we're doing, and this is fine. So step. So let's get back here. And do I want 11 or do I want 19? Let's take a look at this. I think want 19. So let me just 19 is where I really care about this. And one more time. So every time we go through this, we are increasing G by 1 and increasing E by 1. So what that means is, and then the rest of them are not changing. At some point we're going to get here with, let's just say D equals this. And I want to get to when D dot G equals 0. So let's say G equals D dot G. Okay, so D, G plus equals G. And D, E plus equals G. No. Let's try that again. D equals DG equals 0, and then DE plus equals 105,695. So every time this goes up by 1, this goes up by 1 too. So that means we get to and now for a hack, ps dot state, and state is just equals that, and ps dot pause equals 19, right? So at some point we're going to get back to 19 and it will look like that. So let's see what happens now. Day 23 configuration, end of file while scanning string literal, because once again I did not close this. PS dict object has no attribute dict. Okay, so state dot registers. So this needs to be dot registers equals that, and try that again. Okay, so every time we go from 11 up to 19, we are, so let's check this again. I mentioned that I hate this problem because I kind of hate this problem. So compared with the previous one, A is the same, B is the same. D went up by 1, F is the same, E keeps going up, and G. So every time I do this cycle, and now this cycle So it went pretty good. E is 105,970. 105,694. All right. This is making me very sad, but while true, ps.step. Let me. So let me do one more thing here, which is that if self dot state dot get g equals 0. So I only want to print this when g is 0, because that's kind of the only case that's interesting to me. Let's see what happens. So now when I look at this program, so let's look at the program. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Let me just open it over here. That way I'll get line numbers. In 19, I waiting for g to be 0, and then over in 21, I'm setting g to be 0, and then I'm junsing, and then I'm junsing, and then so let's look at a couple of these. So I get to 21, and then the next time it's this. And then the previous time it was this. And then the previous time it was this. And then the previous time it was this. And then previous time it was this. So E is going all over the place, but each time we loop through this, D is increasing and nothing else is happening. And G is always 0. And what am I supposed to check? I'm supposed to be checking register H. And I noticed that register H is not even set. So if I ever get here, I subtract H minus 1. I set G to be B. I subtract off G to be C. I juns. So I'm always going to be junsing here. And I'm always going to be junsing here too. So what I need is I need G to be 0 here. Because if G is 0 here, I'll skip that. Sorry. If G is 0, I won't jump, and then here I'll jump and I'll be done. So I want G to be 0, so that means I need G to be C here. I set G to B, so I need B to be C here. And so how does B become C? Because B and C are not changing throughout this process ever. Set G to B and I subtract G to C. So and then I need F to be 0, and F is always 0, so that's fine. Unless I get, how long have I been recording for? 53 minutes. All right, you know what? I'm not close to solving this, so I'm going to, I know I said I was going to live code every single one of these, but I need to stop and take a break because I'm not getting anywhere. I probably need to eat dinner too. So I will pick up later and hopefully I can figure out how to record two things or to glue two videos together.